Continuing our podcast, my name is Kevin Culp from Supermicro, PM Head of Cloud Management Solutions and Software here at Supermicro. So our podcast continues here. We've been providing video clips on installation and first-time setup of a SCC HA cluster, upgrading that SCC HA cluster, and the previous video of really navigating around the web GUI or logging into the landing page of the SCC appliance that was deployed in our environment. So we focused, like I mentioned, in the web GUI, navigating through there, giving you an idea of different methods to log in and credential, whether it be through global admin or through AD Active Directory service that exists on your enterprise management network. So today we're going to focus on really the architecture of Kubernetes and how SCC rides on top of that Kubernetes high availability clustered environment. By no means is this video going to focus on a deep dive of Kubernetes architecture and understand all the caveats associated with the Kubernetes environment. That's not the purpose of this video. The purpose of this video is to give some general commands that you can issue to understand the health of your SCC HA cluster. And so let's dig into it with this video. So the first thing is I'm going to log in through PuTTY into our VM, our HA node 01 master node, which is our sort of bastion node, if you like, you want to call that term, within our environment. As you recall, we deployed these VMs across each of the KVM hypervisors running CentOS 9. We defined bridges. We had that bridge 1 and bridge 0. So we're coming in through bridge 0, which is the 172.24.199.119. That's the assignment that we provide, or the IP address that we provided to that bridge. So we're going to log in there in under root. So let's go ahead and log in through root. And when we log into root, and hopefully I've put the password in correctly, and I have not. So we've logged into the appliance, and we can, issue IP address show commands to give you an understanding of the various IP addresses and various different kind of bridges that have been set up in this environment. This has a static address of 10.10.0.1 that we provided on the bridge 1 interface. It's going to act as the DHCP mechanism to provide access of IP address scopes to the rest of the HA cluster. You can see here we have 172.24.199.19, which is bridge 0, or the first interface, which is connected into your enterprise management network, on how we came into this platform itself. So how do we get into the Kubernetes environment? What are the commands that we issue in order, and what are those CLI commands that we issue when we get in? So that command we issue is called K9s, K9s, right? K9s. And then we enter into the Kubernetes environment. And you can see here we have a lot of data that we can look at within the K9s SCC or Kubernetes cluster. So to get into the command line of K9s, you're going to do a shift and also a colon. And then that's going to open up the command line interface that you can communicate with the Kubernetes cluster. And the first thing in troubleshooting is trying to determine the status or the health of your Kubernetes environment or SCC HA cluster that rides under Kubernetes, is to issue the nodes command, NODS. And you can see here that we have the 3 nodes, right? The 3 VMs that were deployed, right, within our environment. Remember, these nodes are part of virtual machines that are part of your KVM hypervisor for KVM 1, 2, and 3. So HA node 01 corresponds to KVM 01 node. HA node 2 corresponds to KVM 02, and HA node 03 corresponds to KVM 03. And so the first thing you want to take a look at is, are they ready? The status is ready. If they are not ready, then they have not joined successfully the cluster. That's an important takeaway first. Validating and verifying that the status is ready for the 3 nodes. If the 3 nodes were not ready, you have not defined or built a cluster, and therefore you have no high availability setup, right, for your management environment such as SCC to ride on top of, right? So that's the key, right? Ready state for all 3 nodes, n+1, and remember that we scattered them across multiple racks and potentially different banks within the PDU to be able to support your anti-infinity rule or your high availability cluster. The second thing you want to look at is the versions. This is sort of giving you the versions in which Kubernetes is set up within our environment. And then on general health status of pods that have been deployed, you see 29 for HA node, 38 for HA node 2, and then also HA node 3 has 30 pods. And then you can see the CPU utilization itself in memory, and so on and so forth, right? So general health of the cluster looks very well, right? There's no problems associated with spikes in CPU sitting at 4, 3, and 5. They're relatively idle. So things that you want to take a look at is maybe high percentage of memory utilization or spikes in CPU that may indicate that your HA cluster, Kubernetes cluster, is not working well. And any of the collateral, such as SCC riding on top of that Kubernetes environment, would be impacted, right? So that's a little bit about each of the nodes within the cluster. So if you wanted to look at, say, HA node 0, you would hit the enter key, and there you could see the namespace information. Namespaces are critical here within SuperCloud Composer. So if you look at things there that might be of interest to you, are things like, for example, databases that are currently being utilized, say the SCC cooling tower information as far as what we're communicating with our database, which is Cassandra. We also have PSME agent, right, that is running. And this is collecting metadata, the source of truth in the BMC. So all of our redfish queries and endpoint schemas are utilized through PSME agent. That collateral attributes and payload is pushed up to Pod Manager, which is in control of the entire SCC Kubernetes cluster. So that's in a nutshell from a PSME agent and namespaces. So again, to get back into the command line, you're going to do a shift : again. And at that point, the next thing we're going to do is issue a pods command. So pods is basically showing you the information of this environment here. And that pods environment here is associated with things that are basically associated with status, resource consumption, CPU memory, age and node information, and logs. So pods focuses on that. And then we have what we call the namespace information. So let's do the shift : again and issue pods. And here we see namespace information for each pod. The next thing we want to look at here, let's scroll down a bit and see things that would be of importance to us. Things like an analytics exporter that's collecting metrics data, pod inventory manager, how each of the multi-pod controllers have been deployed through the 10.11 X network. Remember when you initially set up the Kubernetes environment or the SCC cluster, it was riding on that second NIC, right? Or that second bridge 1, which was in that 10 subnet for your CNI, your Kubernetes underlay cloud. And so all of this information, such as SSDP discovery, that would be things that we would discover as far as a compute node through discovery, or setting an IP range when we set up and register that within PodView as the virtualization of servers or compute that are associated with racks, right? So these are all various namespaces that are running under the hood of Kubernetes, providing and utilizing that 10x subnet to communicate across the Kubernetes cluster. So again, we mentioned, 10.x.x.x is really the default that we communicate. We know from previous customers we're talking to in an enterprise, maybe there's a 10.x conflict within their subnet, within their enterprise network. So being able to utilize other subnets that we give you the option and flexibility to plug in during that initial deployment of SCC. So let's look down a little bit more here and see different things. We're seeing IP tables. Here we see SSDP, which is again a mechanism of multicast joins to discover these compute hosts by default. BMC is enabled by default for SSDP, so that's a way that you can discover nodes and add them within the drawer configuration within PodView. Remember, we had two ways to actually discover a node: through an IP range command or through SSDP. So let's look down here and see other things. We can see Helm here, looking at various metrics collection. So these would be metrics collection associated with out-of-band management, such as things like frequency of the CPU, or things like dim temperature of the server, or perhaps even inlet temperature of the chassis, and how we break down all those various analytics, which are out-of-band analytics collection that we collect from the source of truth being the BMC. So let's log down here. We see other things. We see things like Prometheus collection through our cooling tower. So lifecycle management for a liquid-cooled data center is important. If you recall, we used NFS as an external source to provide that capability. So that is set up as an external provisioner. You had to plug in that data when you initially set up, if you recall in the previous videos. Let's scroll down here. Do we see any other information? Yes, we see operator as well. So all of this you can look at. And if you wanted to look at other detailed log information, we could simply, come down to, say, our RKE2 core DNS, and you can look at log information there associated with each of those namespaces to give a better idea of how your cluster is operating and how SCC is running on top of this Kubernetes high availability environment. Okay, so that's from a standpoint of namespaces. The next thing we want to look at is basically deployment. So we're going to do a shift colon again and type in the word deployment here. And when we type in the word deployment, we see actually containers that have been deployed within our environment. And they show up in this particular list, things like cooling tower, NFS. So these are the container images that are been deployed. You can see here two, which are the big ones here for our IP. Supermicro IP SuperCloud Composer is SCC Base, and then SCC Web. So SCC Web is the container that you're connecting to, the GUI, right, to provide you this visualization of lifecycle management, how we've unified your dashboard experience within SuperCloud Composer to collect that specific metadata that makes a DevOps administrator make those data-driven decisions, right? And SCC Base is essentially the baseline or the engine that's SCC or SuperCloud Composer utilizes. And you can see other information here, such as various different SCC analytics and exporters. The exporter for Prometheus and exporter is utilized to get both out-of-band management and also those important GPU performance metrics collection that you want to collect from a GPU. So those are specific containers that are being run in your environment. So let's look at the web itself. And so we can click on web information, and we can look at log information there as well. If we had any logs that were important to us, we could drill down here. So providing this information to our service organization is going to be very important, so they can quickly diagnose your problem and be able to get your environment up as quickly as possible. This information will be vital and useful to our developers so that if there are any associated bugs within the environment, we can easily narrow down those bugs and get your environment up as quickly as possible. Okay, so let's do the shift colon command again. The next thing that we want to look at is services. So we talked about deployments. This is really the inspection of applications, which are the IP of SuperCloud Composer, namespaces and associated metadata. The namespace are resources that are part of basically the Kubernetes environment for our SuperCloud Composer, our own Supermicro IP. And we're also going to look at now services. So we're going to type in the word services here, and let's see what information we can see here from this. You can see here that our cluster has been created. We have a cluster IP. Some of these 10 subnets, as I mentioned before, are those services that are provided using and writing and intercommunicating using that 10.x subnet. Things that we would intercommunicate with for our services would obviously be SCC Web. Our SW agent here is our switch agent to be able to do collection or discovery of our top-of-rack switch provisioning engine, to be able to do lifecycle management for switches, which are part of SuperCloud Composer. We have the SSDP daemon, which talks about, again, our multicast joins, our way of discovering within PodView, and then Prometheus and exporter collection for analytics. So all of this is here for you. We also have our PODM Postgres, which stores all the metadata associated with when a device is registered within SuperCloud's PodView. All of this information gets stored there within that database to be utilized to provide you that unified dashboard experience for lifecycle management. All right, so that's on the services side. We show those are running. You see here we have the external IP, which is the communication out to your management network that is part of your enterprise. If you're utilizing that to communicate with out to provide software dependencies that exist as far as mirrors are existing out on the internet, that information or that outbound IP address will be external and communicate to the internet. If you had an air gapped install, then obviously you wouldn't see this information. Most of that information is provided through our offline installer, which again, you can deploy an SCC HA cluster in air gap mode, which you don't rely on the internet to pull down those software dependencies. All right, so that's on the services piece of things. So the next thing is, how do we look at the general health of the cluster? And that's an interesting command called pulses, Pulses. And you can see here, if we let this run, we see the general health of the cluster. And Pulses is giving you a high-level overview of your cluster's health, right? Again, this is the Kubernetes health, right? We're talking about which in SCC rides on top of to provide that high availability, right, within your environment. And it includes metrics, deployments, stateful sets, and events. So all this information shows up here. And to look at other detailed information of these various different places, you can look at different logs and different information. It shows you here the memory utilization of the cluster is 52%, and then also the CPU is 4%. So the health is actually optimized, right? It's running like what we had expect. If you started seeing spikes in the memory utilization or CPU, that might be an indication that your cluster, Kubernetes cluster, is affected. And obviously, that's going to impact the pods or the containers or the images or services that are running on SuperCloud Composer, right? So getting an idea of this is going to be important to get a general health, high-level view of how your Kubernetes cluster is operating. And the last but not least, the last one we're going to look at, users, which sort of gives you an idea of what users are being utilized within the Kubernetes environment. And we have those showing you there with their different particular roles. And you can look at each of those and what they do, what their responsibility is, right? You can see here things like role-based access control. So we can type in the word RBAC and hit the tab key and fill in the rest of the information. And the RBAC really shows you a role-based access control configuration and shows you dependencies that exist within your clustered environment. So that just sort of gives you a high level of your Kubernetes cluster. By no means is this a deep dive into the whole entire architecture and understanding a complete Kubernetes. The key here is that we provide a self-contained Kubernetes as part of the software bits. So you don't have to be an expert in Kubernetes to really understand how Kubernetes works. We provide that all for you in a base kit. It gets deployed, and basically SCC runs on top of Kubernetes to support your high availability environment. That completes our podcast from installation to upgrade to logging into the web GUI to getting a little bit of a high level view of your Kubernetes cluster. Hopefully these videos are helpful. I'm getting lots of feedback back from subscribers. Thank you for continuing to subscribe to this YouTube channel. I'm hopeful these videos have been informative for you. The intent and mission of my team is to provide the most innovative software in the industry to support your AI infrastructure and your enterprise as far as general compute is concerned. Supermicro's focus on software is important from an enterprise management solution. It's very, very important to Supermicro. And my team is leading that charge and strategy and mission within our Supermicro team. So again, thanks for joining. I wish you the best day today, and we'll see you next time as we continue to roll out new important videos that will help you understand the mission of enterprise management, both in an AI infrastructure, in a liquid-cooled data center, and also in general compute in the enterprise. Thanks for joining. We'll see you next time.